Hello everyone, this is Dipesh Agarwal, working as Technical Support Engineer in MIDAS IT. I am welcoming you all on this webinar series in which today we are particularly focusing on MIDAS FEA, which is a detailed finite element nonlinear analysis software in which advanced analysis can be done. So in this series, what I will do, first I will introduce our software MIDAS FEA, like what is the importance of detailed analysis, and then what are the capability of the software provided by the MIDAS. And then afterwards, I'll tell about the integrity between the MIDAS Civil and MIDAS FEA. Like generally what we do, we simulate the bridges or any building as a line model. Because as we know that if we do solid modeling, it will take more computational time and more time to interpret the results also. So generally what we do, we simulate the bridges as a line model, means beam model, which has 6 degrees of freedom in the translation as well as rotation degree of freedom. So I'll model a bridge, like I have one model prepared in the MIDAS Civil. MIDAS Civil is a software which is used for bridges, like simple bridges to high-end bridges like box culvert, slab bridge, to high-end bridges like cable stayed suspension bridge. These analysis and design can be done in MIDAS Civil. But for the detailed analysis like local stress check, crack propagation, we have to do the detailed finite element analysis. For this, what we will do, we will export the MIDAS Civil file, which is a line or beam model, to MIDAS FEA for solid. So we will see how it is quick to generate a solid model with the help of MIDAS Civil with a line model. So first, I would like to begin with MIDAS FEA Introduction. So basically this is a software which is used for advanced nonlinear analysis and detailed finite element analysis. Now what is the use of detailed analysis? First question comes to mind, why use MIDAS FEA? So there are some major area and bridges where MIDAS FEA is quite commonly used. Let's say the beams and girder are connected in a complex way. I'll just on my pointer. One second. So here you can see that beam and girders are connected in a complex way. In a frame, if it is a frame type of modeling or then beam type of modeling like do in MIDAS Civil, this joint is modeled as a node. In that case, we cannot get the concentration of stresses. To get this concentration of stresses in the joint, MIDAS FEA is useful. Next, in the bridge connection, generally the steel trusses are resting over the pier cap. You can see over here, at that location there is big stress concentration, and hence to get these stresses and identify if they satisfy the stress limit or not, we have to go for finite element model. Similarly, for concrete cracking, MIDAS FEA provides total strain crack model to simulate the cracking of concrete as per the non-linear behavior, and as a result to get the cracking pattern, the location of the smeared cracking, and also get the width of the crack. In that case, MIDAS FEA is again useful. Next is, you can see it is a pier deformation. When we talk about deep beam, let's say this is a deep beam, solid modeling is very much necessary. Why? Because if we go for frame type of modeling, then the results are not as much accurate. So for getting accuracy, we have to go for solid modeling of the deep beams, which is a proper approach, and hence here you can see MIDAS FEA is useful. Next, you can see it is a steel corrugated web bridge. It can be modeled in the MIDAS Civil also, but we cannot get the stresses in the corrugation, and it is not much detailed also in Civil as compared to FEA. So more detailed model, more detailed results. Next is steel concrete girder connection. So it can be modeled in the Civil also, but it is limited to the major type of composite section. When it comes to a steel concrete girder like complex type of thing, then we have to model it. It is in MIDAS FEA, and some detailed results are also required over here, so that can be obtained from software MIDAS FEA. Next you can see curved steel box girder is there. So here you can see MIDAS, this bridge profile is curved, and then in this crucial results are distortion and warping stress. So for getting these results we cannot get in frame modeling, we have to do the solid or plate modeling for getting the distortion and warping stresses. So that can be done again in the MIDAS FEA. Next again example is the bifurcating webs. You can see over here. Here the stress concentration will be at the location of the bifurcation. So to get the accurate stresses in this crucial location, we need to go for detailed finite element analysis, which will be done in MIDAS FEA. Now next is coming to this bolt connection. Here you can see if we are modeling in MIDAS Civil, so these connections are modeled as a node. The connection between the beam and column is modeled as a single node, so we cannot get the stress concentration over the node. So to get this and to know where bolt connection or connections are failing or passing, we have to do the detailed finite element analysis over here, which can be done in MIDAS FEA. Next is you can say split saddle. It is a model in suspension bridge. It is a real-time project application of suspension bridge. In this case, what is happening? Steel flange are piercing into the steel body. So here the stress concentration is exceeding the stress limit. Here you can see. So which cannot be known in the MIDAS Civil, because we are not modeling the detailed structure. So for that again MIDAS FEA useful. Next you can see over here orthotropic steel deck is there. If we use the frame modeling over here, local buckling cannot be checked. Yes, design codes give some limits for considering the buckling, but that is again approximate approach. But for accurate local buckling stresses, we need to model it in MIDAS FEA. Next you can see MIDAS FEA is also provide the CFD analysis, which is computational fluid dynamic analysis, which is very useful when we have dynamic effect in bridges structures. Then we can model the section into FEA and analyze for computational fluid dynamics. After seeing it, we can understand that how important MIDAS FEA is in real-time projects. Now you can see, now I would like to highlight the capability of the software, particularly MIDAS FEA. Previously it was the usefulness of MIDAS FEA. So here you can see in MIDAS FEA we can import geometry. Any type of complex geometry can be imported from the solid geometry software like Parasolid, Nestran, etc. Also the geometry can be imported from the other MIDAS products like MIDAS Civil, MIDAS Gen, and we can import this, we can export this geometry to MIDAS Civil Gen again, and other software like FIGES, Nestran, etc. This particularly we will do in our session. What here in Civil and Gen we have frame model like line model. Simple, we have simulated the intersection by a line, but we want to do the detailed analysis. For that, what we can do, we can directly export this section to FEA, and here it will convert into solid. There we can mesh it and we can get the detailed analysis, detailed results also for solid modeling. So this we will do. Now coming to analysis scope of the MIDAS FEA. So MIDAS FEA is capable of handling any type of analysis, right from the static analysis to construction stage, moving load model analysis, also dynamic analysis like time history analysis, response spectrum analysis, nonlinear analysis like material geometry, nonlinear analysis. If we want to do the crack analysis, fatigue analysis, heat of hydration analysis, as well as we can do fluid dynamic analysis. There are some projects applications which are done using MIDAS FEA. One you can see this Woomnam extra dose brace. So here what is MIDAS FEA used for single pier. It was analyzed in MIDAS FEA for checking the stresses for checking the detailed stresses at this encouraged location, and the dynamic analysis was also performed. Similarly here you can see. Next we have Next we have this steel arch bridge, in which only a portion of the bridge was analyzed using MIDAS FEA for detailed analysis, detailed stress concentration at these locations. Next example is a hanger clamp. When we go for flame modeling, we connect hanger to the cable just through a nodes. So, but at this node we have hanger clamps also. At this hanger clamp, the stress concentration is very high, and if we do not consider the stresses at this hanger clamp, so we are just assuming that the clamps are sufficient enough to resist the load, but that might not be the case. So for that, MIDAS FEA were used. Next is fatigue analysis, then CFT analysis. So next is contact analysis, where we can simulate the contact between the plates and the pins. So this was about the MIDAS FEA, this basic introduction of the MIDAS FEA capabilities and the project application. Now I would like to come our tutorial, or you can see our so here you can see this is a bridge model in MIDAS Civil, which is made in MIDAS Civil, where bridge type is single span PSC box girder. Pre-stressing is done by post-tension method. Tendons are provided over here. Span length is 40 meter, width is 8.5 meter. Bridge was designed in MIDAS Civil using IRC 112-2011 code, and here time-dependent material property for the concrete is also defined as per IRC 112-2000. Here moving load analysis was also done, but we have simulated the entire bridge model by a single line. So, but as I said, when we do model as a line, we cannot get the stress in the depth of the section, like detailed stress concentration and other things like crack propagation. So for doing crack propagation and the detailed stress strain analysis, we exported this line into the solid for MIDAS FEA. So first I would like to give a brief review like what we are going to do, then we will move forward to our software. So here you can see this is the model in MIDAS FEA. Previously it was model in the MIDAS Civil, which is a line model, but right now it is a solid model in MIDAS FEA. Meshing has been done over here, detailed meshing, so that we can get detailed results. So here you can see tendons are also provided over here in MIDAS FEA. So this is a longitudinal view of the bridge, and that the section property is according to that, and boundary conditions are provided as simply supported boundary conditions over here. This section was defined in the MIDAS Civil, so we don't have to define the section again in the MIDAS FEA. We can directly import that line model into MIDAS FEA. There it will make the solid of the section. So here you can see this is the bearing or supports layout for making it simply supported. In MIDAS Civil, MIDAS FEA, the material property for the concrete was done as isotropic, where elastic modulus Poisson's ratio as per shown on the screen, unit weight. But for checking the detailed strain crack propagation, we use total strain crack model, where we can get lateral crack effect as well as confinement effect, where for tension softening we have modeled as a Hodgick model where properties are likewise, and for compression softening we have used Thorenfeld, and element is solid 3D. For steel reinforcement we have used isotropic. For longitudinal bottom end shear was provided according to this Poisson ratio, and one Mises were used for reinforcement as well as for tendons also. So here you can see what elements use. We have one particular element in MIDAS FEA's embedded reinforcement bar type. What it does mean, like we have to ensure the connectivity between the solid concrete and the reinforcement, like node of the reinforcement and the node of the concrete should be connected properly so that force transfer can be done properly. For that, in other software we have in MIDAS FEA we don't have to care about the connectivity. Program will automatically connect these two nodes by providing the embedded reinforcement. Mean the proper connectivity is ensured between the concrete and the reinforcement. Next, I would like to give a brief idea of the total strain crack model in MIDAS FEA. So here two things are there. First, we can define whether crack model is fixed or rotating. Means if my crack plane is fixed, if I want to fix the crack planes, then we can use fixed, otherwise we can use rotating. Generally in 2D type of model, we use this fixed type of crack model, otherwise it is recommended to use of rotating type. Then we can use stiffness as secant. Then crack effect, we want to know about lateral crack effect and confinement effect then. And also tension, compression, shear function can be defined over here. I would tell about this. This graph you can see over here. When there is no confinement, there will be large deformation at very low stress, and as the confinement is increasing, like triaxial loading, the deformation will be less for the particular stress. So these are various options for total strain check provided by the MIDAS FEA for compression as well as tension and shear. Like compression, you can see elastic, constant, Thorne field. In this particular problem, I use this Thorne field, and then for tension, I use Horgy. So here you can see, I would like to highlight first about this compression softening and tension softening. So what is tension softening? When the tensile force is going beyond the tensile strength, like I am increasing the tensile force and it is going beyond the tensile strength which is defined in the software, then in this case deformation or deflection will increase but the tensile strength would decrease. So here you can see in this, my deformation is increasing but the tensile stress is decreasing. So this phenomena is called as tension softening. Similarly, and when this tensile stress reaches to 0, then micro crack would be generated. So this phenomena is again called tension softening. Now for compression softening, when we provide the confinement, when the tensile force is perpendicular to the compressive strength or force, when the tensile force is perpendicular to the compressive force, in that case there is reduction in the compressive strength. This is called compression softening, which can be modeled by various models. So here next is analysis part. So in analysis we have applied the prescribed displacement. We can apply loadings also, but loadings can be applied in multiple steps or it is again dependent on the users. And we have used rigid links. What does it mean by rigid links? When loadings and boundary condition loadings are to be applied at various nodes, then we can connect to various nodes by the rigid link and we can provide the displacement at one node. So this distribute the forces to other nodes linked by the rigid link. Same for boundary condition. So here we have done nonlinear static analysis, where this is the output, like which results we want to get in our output file. So here you can see I have checked on this crack strains, crack stresses, so that I can check cracks also. So this was about the analysis type. Now nonlinear analysis, then we have to tell the software about the nonlinear analysis control. So here various type of iteration schemes are provided by the MIDAS FEA, like initial stiffness, neutral reaction, modified neutral reaction, arc length. So for crack propagation and cyclic loading, it is recommended to use arc length, but it is again dependent on the user which method he wants to use. Now if we have to tell about the convergence criteria, if the analysis is diverging, then we need to terminate the analysis so that we can check where fracture is happening. So this was the nonlinear analysis control. This is the material property which are defined in the MIDAS Civil. So MIDAS Civil, creep, shrinkage, compressive strengths are defined, and also we have defined it in MIDAS FEA also according to IRC 112 code. So this was the section as I said. So now coming to results part. After the analysis we have to check the results. So in MIDAS Civil, as I said, we are modeling the complete bridge as a line model. So here we can check results like bending moment, shear force, stresses, strains, tendon losses, but only at a line. Here you can see the bending moment diagram. If you want to check the detailed results like crack propagation, these results are propagated, then we have to do the MIDAS FEA. So this was about the workflow. In case you have any doubt, you can ask me. Now we will move forward to our software, MIDAS Civil and FEA. So This is the MIDAS civil, in which you can see we can model bridges like suspension, cable stayed, ILM, FCM bridge, 2RC slab, box steel composite, pre-stress composite. We can do railway structure interaction analysis over here. So this is a box girder bridge, single span box girder bridge. Here you can see it. This is a work tree. Meaning here we can see the input parameters which we have provided to the model and the progress of the modeling. So here you can see I have used beam type of element which has 6 degree. If I check on this hidden view, here you can see entire bridge is modeled as line element. So here if I want to check the detailed stresses, I can check, and for crack propagation and all, I have to use the detailed finite element software which is MIDAS FEA. So, and the material used over here is M45 for the concrete and Fe540 for the tendons. And we have defined the two time dependent material property for creep and shrinkage according to IRC 112 code, and for compressive strength also. And then we have limited to concrete, and sections I have defined as box girder section. I will show you. This is the box girder section over here, which I have defined over here. This is the pictorial view of the PSG section. So this was the section which we have taken over here. Then we have provided 4 supports and elastic links are provided for to simulate the bearings. We can see these all things over here in display option. If I want to check, then I can check. So these things are provided over here likewise. And then load case, self-fit, and 2 tendons are provided. Just to multiple tendons can be provided over here. But to simplify the model, and just to demonstrate, we have provided a 1 tendon and moving load analysis also. Now I want to do the detailed analysis in MIDAS FEA. So what can we do? I can export this model to the frame section for solid. Like we are converting the frame section, beam section into the solid. So in file there is option export, in which one option is provided like frame section for solid. Other options are also there. You can explore these options. Frame section for solid. So just and here a program will ask where you want all elements or object elements, and you want tendon profile or not. So I want to import the tendon profile also. Then click on OK and you can save it. So I'm saving it and over here. So I can save it also. One second. I can save it. Now it will directly save it. Now I'll move forward to our other software, MIDAS FEA. So this is the MIDAS FEA software. So if I click on here new file, it will click and unit can be changed over here. So this is the basic interface of the MIDAS FEA. First let's see about the interface. So this is the interface. Here you can see we can import the file from the AutoCAD if we have geometry. If we have MXT file which is MIDAS Gen Civil, we can import that file also. If we have advanced geometry, in that we can import the model from the STAB, IGS, others also Parasolid. So this was about import. Then we can import the model to the Civil Gen, again to pre-neutral and Nestran. Here you can see unit system preferences can be changed over here. Open, save, these are the functions available over here. Right now in geometry we can do the in finite element. What we have to do, first we have to make the geometry, then we do the meshing. While doing the meshing we have to assign the material and the section property, and then we can apply the boundary condition and then loadings, and after that we can do the analysis. So here in the geometry in the geometry tab, we can define the geometry over here. Like we can define point, curve. In curve, various things are there: fillet, chamfer, trim, intersect, and surfaces. We can make solids, primitive feature like cylinder, box. If you want to box, wedge, sphere, that we can made over here. There is AutoCAD commands are also there: extrude, revolve, loft, sweep. Then we can cut. Boolean operations are also there. Fuse, cut. So these are various options. And again there is option frame to solid. So as I said, I want to import that solid file. So here I have to select that file. I'll select, and then it is importing that file. So here you can see, and then click on OK. So here you can see I have imported a line model to make my solid model. So it is pre-works, which is like work tree menu. It is post-work. After the analysis, you can check the results over here. Pre-works, all the input parameters which we have provided over here will be seen over here. So here you can see we have imported the solid, which was line in the MIDAS Civil, and two cursor tendons are also imported over here. So tendons are there, and so this is now only geometry. Now we have to mesh it for the detailed finite element analysis. This is simple geometry, so that can be done. Or if you want to make the geometry by your own self, that can be prepared in this geometry tab. Then we have to do the meshing. So there are various options for meshing, like auto mesh options are there, in which we can do meshing for edge, face, solid. We have various elements for the finite element analysis, like we have hexa solid elements, tetrahedron, triangular elements over here, and we can provide the mid side node also. Let's say I will select this solid first, and then here you can see advanced option. So here I can select the mid side node also. So this is the thing. Now first we have to define the procedure is same as in MIDAS Civil and FEA. So after creating the geometry, we have to define the material and then the meshing property. So for that we can go to analysis, then we can go to material, we can create, and here I am defining three material here I am defining the two material. I am not providing the reinforcement over here. If you want to provide, that also can be provided over here. So two materials I will define for the concrete as well as for the tendons. So first material I am entering the name as concrete. Then elastic modulus we have to provide. 1 second. Let me. So these material property can be defined over here. So I'm providing as elastic modulus as 50,000 Newton per mm square. So likewise I'm providing and then weight density I have to provide. So this will be 25,000 Newton per meter cube. Then Poisson ratio I'm providing is 0.3. Then the model is total strain cake. As I said, we are using total strain cake. Crack model we are using as rotating. We don't want to fix the crack plane over here. Then for lateral crack effect and confinement effect, we are using this Collins and Jessicho model. And for tension, compression and shear function, I have to define it. So that can be defined over here only. So just click on this icon and this will open a window like over here. Then here I can select tension, we can enter the name as tension only, and then we can select the function type as always. As I said, I am just defining the Hodgkin type of model for the tensile softening function. Here I can define the FT. So these properties are like you can see over here. This is the FT and GF is the slope of that. These parameters we have to input over here. So these parameters again depends on your study, and then I am providing as 0.025 as H, and then I can click on OK, apply or OK. So tension function is defined. Similarly, I can define the compression function. So I can select the compression over here. For compression, as I said, I am using Thorenfeld type of section, the Thoren type of model over here. So that can be selected, and then we have to define the value, like at which the strength you can see. So this value I have inputted over here, and then OK. So here we can select tension and then compression. Shear, if you want to define, that can be defined over here. Then click on apply. So here you can see concrete is defined. Similarly, I have to define the tendon material, that can be defined. So tendon material properties I have to enter. So the properties over here is elastic modulus, then I have to enter the Poisson ratio, then I have to enter the weight density. These values can be defined. Here for the tendons, I am taking the von Mises material model. So here I have to enter the initial yield strength. So that can be entered over here, and then click on OK. So two materials I have defined over here. Next, what I have to do, I have to define the time dependent material property. If I want to define, that can be defined over here. Creep and shrinkage and compressive strength. Just right click on this. It will provide option to add. Here we can enter like first name. Name can be entered as C and S compressive strength, and then code can be selected over here. So CBPIF code is available there, and then show results you can click, and then OK. So likewise compressive strength also can be defined. Just enter the name, and we can use the code over here CBPIF. Here value also can be provided. And then the draw graph, and so likewise I can provide the creep and shrinkage and compressive strength. Now I have to define the mesh. So for mesh we have to define the property. So in property you can click on this property. Here I am defining a 3-dimensional property like solid element for the concrete. So that name can be entered over solid element, and the material is solid. Then I have to define the reinforcement type of embedded reinforcement. As I said, we need to be ensured that the connectivity between the concrete block and the tendons are properly there, so that forces can be transferred from one material to another material. For that we have reinforcement type of element in which embedment between these two elements are ensured by the program itself. So here I am defining the reinforcement. First we need to define the bar section. So I am just entering the name as tendon, click on apply, and then we have to define the property of the tendon. So here I can select the material of the tendon, then I need to enter the area of the tendon. So that can be entered accordingly. So let's see what I have defined over here. I have to check in a second. The area over here is 0.0026 meters square, Then it is of tendon type, so I have selected tendon type, and the code for the time domain properties can be used over here, and then click on OK. So I have defined the tendon property. After this, we need to create a mesh over here. So that can be created by clicking on mesh. There is option auto mesh. We can auto mesh, and also we can do map mesh. So we can click on there. First we will mesh the solid part. So we need to select the solid first. That can be selected over here, and then we need to provide the element size. So I have provided 1 meter. That can be reduce or increase, and then I can enter the name. So I am entering the name as concrete, and then we can click on preview. So here you can see meshing has been done. Click on OK. So the meshing for the solid element is done. Now I have to do the meshing for the edges, which are tendons. So I can click on auto mesh and then edge. So I can select the edges. So these 2 edges I need to do. So here you can see 2 edges are selected. So these 2 tendons are, then I can provide the number of division, which I am taking as by default 10 mil, and then I can enter the name. So I am entering the name as tendon, and then it is more or less this reinforcement type, like connectivity will be there between the solid element and this tendon element, and then click on OK. So the meshing has been generated. Now I have to apply the boundary condition over here, then loading. So here this is a work tree. If you want to check only the geometry, you can click on show only. If you want to hide the mesh set, just click on that and hide. So the mesh set will be hide. Likewise, we can play with this tree menu, and I'm just clicking on show all. So this was just to explore the about the tree menu. Next, I would like to apply the boundary condition. That can be applied in BC, and just click on constraint. Here name can be entered in case of multiple boundary, and then we want to apply the boundary condition with the nodes. Then we have to select the nodes. These 4 nodes I have to select. So just I am selecting these 4 nodes, and then these are various view options. ISO view, front view, side view, back view. These are various options over here. You can see over here. And these are various options for creating the curve, surface, or the geometry. This is the option for select all. So this option can be explored. These are the options for undo, redo, likewise. So 2 nodes I have selected. I have to select these 2 nodes also. And by holding your wheel, you can rotate this, and then 4 nodes are selected. Then I show you. Then I am applying this fixed type of boundary condition just to check that and apply. So boundary conditions are applied. Now, as I was saying, that I need to apply the displacement over that node. So we have to connect these nodes to other nodes so that displacement can be applied over all the points. So that can be applied by creating the rigid link. That can be created in the mesh tab. Mesh, when we go to element, there is option create link. That can be clicked over here. This provides the option where you want to create the rigid link or elastic link. If you want to create the rigid link, the difference between rigid link and elastic link is rigid link means the very high stiffness element is there. So it will impose the boundary conditions at the slave node as per the master node, like the degree of freedom and degree of freedom you can say experienced by the master node will be also experienced by the slave node. Then select master node I have to select. So this master node I have selected, and similarly I have to select this slave nodes. So slave node can be selected like here. Sorry. So slave node have been selected. Then we need to define the property, like in which direction we want to provide a rigid body. So I want to provide in all directions. So I can click on rigid body and then enter the name as rigid link. then OK. I can select this property and enter the name if you want, and then click on apply. So links has been created over here, you can see. Similarly on the other side also I need to create a link. So for that I need to select that node, and then I need to select the slave node. So master node is the node, slave nodes and master nodes, there is concept for the resulting. Master node is a node which is governing the governing node for the degree of freedom, and slave node is the node of which degree of freedom are dependent on the master node. So master node should be 1 and the slave node can be any one. Click on slave node and then click on OK. So likewise I can create the resulting on the two sides. Then I need to apply the forces, so that can be applied again in load. So here I am going to apply first is self it, so that can be entered under the body force. I can enter the name as BW. Then because the gravity direction is my opposite to the z direction, so I need to enter the factor as -1. So body force can be applied here. In work 3 you can see what I have inputted over here. Then I can apply the tendon forces over here also. Then load, and there is option re-stress for reinforcement that can be applied. I can enter the name as PS. Then I need to select the reinforcement. So I have these two reinforcement that can be selected, and then I can impart the force, or if you want to apply the force also, that can be selected. So I want to apply the pre-stress and force. If it is post tension, that can be selected. If you want to checking on both sides, begin and end both, that can be selected, and the value can be entered over here. So this value again I am entering, and then OK. So this is about the loading condition, then boundaries, and then the meshing. So everything is now generated. Now we have to do the analysis. Before analysis we have to tell the software which type of analysis we are going to do. So that can be simulated in the software in the analysis case tab, analysis, then analysis case, and then click on add. So here I am various options are provided by the MIDAS FEA for the analysis, like linear, static, eigenvalue, buckling, time history, response spectrum, nonlinear analysis, heat of hydration, movement load analysis. So here I am doing nonlinear analysis, nonlinear static analysis, and I can enter the name as N. So just make sure MIDAS Gen provides the option for multiple analysis simultaneously in the model. So here we can make different multiple analysis case, and we can also select which mesh, geometry, boundary condition should be in particular analysis. So here because we are doing only one analysis, so that all the mesh set will be in this analysis BC, so that can be selected likewise. And then we have to select the output control, output type. So I want crack results, so you can select all results, and then analysis, nonlinear analysis option. So here options are there like initial stiffness, modifying Newton option, or outlet. Here this time using Newton option, the user can select anyone. Then we have to tell the number of load steps. So here I am entering the number of load steps as 5. That can be entered, and then close. Then I need to do the analysis. So that can be solve and OK. So here it will ask for saving it. So I am just saving it. Yes, pre-stress box girder and save. So here you can see if we have multiple analysis, we can tell the software for which analysis case we want to analyze particular time. So that can be done. So this FEA solver is analyzing. So in message window, we can see the saturations are performing, and this is the convergence criteria. Here you can see if it is too much, then we can say the program is not, solution is not converging, but it is -1. So likewise you can check where my fracture or crack is coming in the model. So likewise we can do analysis. So I have entered 8 now 5 number of steps, load steps, and so it is analyzing. So here you can see MIDAS job is successfully completed. Now we can check the results. So here I have provided 5 steps. So loading has been applied in 5 steps over here. So this is the post. Here we can check the react, displacement, strengths, stresses, and reinforcement. Then crack pattern we can check, and likewise. So if I want to check the cracking, so here we can check the cracking has been done over here, and the ultimate load complete has been cracked. If I want to check it for 0.4 second load step, that can be checked. So here only some concrete has been cracked over here. Status, if you want to check, that also can be checked, whether it has been partially open, unloading, closed, that can be checked over here. So this was about the MIDAS FEA. Other results also can be checked, like displacement, stress resistance. So this was about the MIDAS FEA and the MIDAS Civil. Hope you liked the video. In case you have any doubt, you can write us a mail on deepesh@midasit.com or globalsupport@midasinfo.com. Thank you for listening.